Now let's move into talk a little bit about that now and see what we can find for a little bit here. So I thought I would start just with looking at a satellite image. When you look at this satellite image, what I notice is, gee, right along this area, there's a change. Notice it's kind of hazy. Doesn't look like there's any bubbly clouds much back here. And out in the west, man, there's nothing. It's really dry looking, isn't it? You can see the ground. Now, but ahead of that, what do I see? I see lots of bubbly clouds, a lot of what looks like maybe thunderstorms in here, probably some more off the coast here, even some more out here in Oklahoma and stuff. So if I'm relating this, I'm saying, well, there's a change in air mass somewhere along this boundary. And if I have a change in air mass, I have a front. And depending on which way that front's moving, it might influence what I have, type of front it is. The cold air is advancing, it's a cold front. The warm air is advancing, it's a warm front. Oh yeah, I'm also, if I watch it real close, I almost see like a circulation, a counterclockwise circulation there. A little hard to spot, but take my word for it, it's kind of there. We'll just cut this off. So with that, if I have that little circulation there, well, if I look aloft, there's actually a little bit right in here as well. Not much, kind of more open, but a little bit there. It's not a very strong low. By the north, yes, here's a strong low. So with that, we said we might have some fronts and stuff there. Well, let's see whether we do or not. Well, golly, there's your front. There's a cold front. It's a kind of stationary front, actually, down to the south. And there's another cold front where we saw that upper low there at 850 millibars back here, pushing some colder air down. So we have a very distinct warm, probably almost tropical kind of air mass here, cooler back in here, and much cooler. I mean, temperatures are in the 50s back here. Summertime, not supposed to do that. At least I don't want it to do that in the summertime. And you can see along this pattern right here is the radar, and you can see a lot of showers and stuff right along with that front. And that little bit of circulation seems to be helping to enhance these showers. Well, if I look at the loft, what I'm seeing is a jet. And that jet, we've learned a little bit last video about where the divergence and convergence are. Well, to the left front of this is a divergent region. So I should be getting lifting. To the right rear is a divergent region. I should be getting lifting. Guess what? That lines up really, really well with where that little circulation was I looked at, and where the all that precipitation and stuff moving across it into Ohio and all comes out of. So really good correspondence here with that upper jet moving through right now. Forecasting how that's going to change is a forecast. That's what we're interested really in. We're learned why we have what we have right now. We haven't learned where that's headed yet. So that's out in the future a little bit here. That's really the hardest part, picking out, okay, we know why the weather is occurring and what's going on now. What's going to happen a day from now? So let's look a little bit with this, learn a little bit more. We got to learn it first. About where air masses form. Air masses are large bodies of air, all about the same. We get Arctic air masses. Obviously, they come out of the Arctic. We have maritime polar air masses. Guess what? They come out over the cold oceans. In other words, northern Pacific, northern Atlantic. Tropical air masses, we can get continental tropical, which are dry, coming out of the desert Southwest. And maybe we get maritime tropical coming out of the Gulf of Mexico. And the continental polar we get coming out of most of Canada. So you can see here the different places these air masses tend to form. And we already learned we get some areas of high pressure around these spots. So when these air masses begin to move and move away from their area, they begin to modify. So if I live in Ohio, where you all do, when the air mass comes out of Canada, it's going to have one temperature, probably pretty cold if it's a really, really cold air mass. Well, guess what? By the time that same air mass gets all the way to my house down here in Southeast Virginia, it's had to maybe move over no snow cover. I'm going to assume that maybe there's no snow cover there. Well, that's going to heat the ground up, going to heat the air mass up. Oh, yeah, it's coming down the Appalachians. It's moving down slope. What happens when it's compressed? It warms. So all that is why I don't have as many cold nights and days as you have in Ohio. So where these air masses meet is a boundary. We looked at it, and I showed you on the current satellite pictures. Is kind of a stationary front, not moving much one way or another. Well, along the stationary front, remember, warm air is going to rise, so the east side, where the warm air was, is rising up and over the cold air to the west. So where that's occurring is where you're going to get the most precip, right along the boundary, and further away from that, the clouds are going to get less and less when you're in the cold air. So that's actually one of the interesting things when you're on the cold side of this. Typically, you have clouds extending a little further your direction than you may have on the warm side. When you have a non-motion, a warm front, same thing. The warm front just means the warm air is advancing. Cold front, on the other hand, well, the cold air is advancing, and cold air is denser. It's going to have a steeper slope. In other words, it rises very quickly and much thicker. Notice, say I was 50 miles, 100 miles behind the cold front. Now, the cold air is a lot thicker than right at the surface. Same holds true. You might actually be in the warm air, not relative, but if you're high enough, and you can see here what we call backdoor cold fronts. I hate them because they come down on the east side of the Appalachians. They'll drive down from New England. They have a maritime polar air mass typically with them. They bring a lot of clouds, drizzle. They tend to make life miserable along the eastern United States. And they tend to occur a lot in the spring and sometimes in the late fall. So times when I want to see the sun and have nice weather is when these happen to pop up. Occluded fronts. What are occluded fronts? Well, if you have a cold front moving along, coming in behind the low pressure, and out ahead of that low pressure, you have a warm front, at some point, that warm air gets overtaken by the cold air from the west. Maybe the air is not as cool, but ahead of that warm front, there's some colder air. So that pushes that warm air aloft. When the cold front to the west is overdoing it, is what's called a cold occlusion. When it's actually the warm front would have been to the east, and the cold air to the west isn't as cold as actually what was to the east, you wind up with a warm type occlusion. Norwegian cyclone model. Bjerknes invented this many years ago, and it works. All it says is how an extratropical, and notice the key word I said, extratropical. These are not tropical cyclones. Developed. What happens is you have that little short wave we talked about. Well, it gets a little stronger. And because of the divergence aloft, a little more divergence occurs. That low pressure gets a little bit stronger as well at the surface. You develop a little more pronounced cold front and a little more pronounced warm front. And eventually, you will with a little bit of an occluded front, and eventually you get a very strong occluded front, wrapping all the way back. Notice the clouds. They form a comma head. That is the sign of a mature extratropical cyclone. And yes, you get these in Ohio. You get them everywhere in the United States. And these occur in Ohio probably every 3 to 5 days during the wintertime. You have one of these go by you, either to your west or to your east, or maybe to your north, or even to your south, but they're impacting your area. Most times it's going to rain in the wintertime is because you've impacted some part of an extratropical cyclone. So here you can see the birth of it, how it develops into an open wave, more occlusion, and finally really bent back. There's another model. Let's go back one here. I want to show you this model. This is called the conveyor belt model. It was developed by Dr. Carlson. And what happens is low levels. You have a cold high pressure to the northeast of the low, typically. So it's pushing cold, we'll say damp air coming off the Atlantic into it. That air is moving west. Underneath that lies a warm conveyor belt of warm, moist air. That lifts up and over that cold air. Under it is the cold conveyor belt. What happens eventually, that cold conveyor belt gets lifted high enough, it gets hit by the westerlies and moves back to the east. That is how your comma head formed. It's all related to the motion of that cold conveyor belt. So I want you to understand that because you're going to probably have a question with that on it. Different parts of the cyclone, different kind of weather. And cyclones take all kinds of different tracks. Notice the Colorado cyclone moves up through, develops over Colorado and moves across Alberta, develops. So which one is closer to a source of moisture? Well, the Colorado low is a lot closer. And whichever track they take, the closer they are to the Gulf or the East Coast of the United States, the more moisture they're going to have available to them. So the more potential for heavier precipitation. Depending on which side of the extratropical cyclone you are in the wintertime is what kind of weather you're going to get. If you stay on the northwest and west side of it, you're probably going to get mostly snow or some mix. If you go to the east side of it, you may start out as snow, maybe even change into freezing rain, but eventually you're probably going to change into all rain as the warm front. And then to the south, along the cold front, typically storms to the east. So depending on where these go, and you could be off 50 to 100 miles and make a huge difference on your weather. So that's why when you're looking 3 to 5 days out and you hear an extratropical low that may be intense, it's coming to Ohio. Well, if that low goes in the western part of the Ohio, the eastern part's going to wind up with a lot of rain. If that low went in the eastern part of Ohio instead, they may be getting a little bit more snow. It makes a huge difference. Cold core versus warm core. I talked in the last video some about this, how temperatures decrease faster with cold air. Well, that means in an extratropical cold core system, the strongest and most intense low pressure is aloft because the temperature is decreased. Pressure is decreased as well. Cold core. Warm core, on the other hand, thermal lows, like I showed you out west there. And here we have the anticyclones tend to come in after these extratropical cyclones. And I wanted to show one last thing, a little bit. There's lake breezes and sea breezes that occur. And get that one up back here a minute. It's going to be a little slow on me here, sorry. But lake breezes, we'll just describe them off of Lake Michigan, for example. Michigan, think of it in the wintertime, or in the spring especially. Water over that lake is cold. So that means the air is going to tend to want to sink down. Convection doesn't occur over warm water, while the convection is occurring over the warmer land. So if the convection develops over the land, air is going to tend to want to lift there. We're going to start moving it in from the lake. We wind up with a sea breeze. Same thing holds at night, just the opposite impact. Mountain and valley breezes are very similar. They're based on topography and the amount of warming the sun does. So hope you got a little bit out of this, and let me know if you have any more questions.